Today I'll talk about data presentation. This is raw data of thesis of one of my student. Uh, she studied uh, characteristics of patients of breast carcinoma, and these are columns of various attributes and variables. Like for example, in column E, there is age. In then column G, there is menopausal status. The variable age, as you can understand, it is a numerical continuous variable, whereas variable G, that is menopausal status, is a categorical data, nominal type. It has two options, yes or no. So then there is a variable or an attribute known as lymph node stage. It is there in column J. As you can see, it has options of 1, 2, and 3. So these are actually some of the variables and attributes she studied. Now, by looking at this raw data, it is very difficult uh, to to understand it, to infer something from it. So we need to do a data presentation. So data presentation is the presentation of data in either pictorial or diagrammatic or graphical manner. There is subtle differences between pictorial, diagrammatic, and graphical terms. Uh, the important thing is that appropriate graph must be selected for presentation of a particular data type. So the selection of graph depend on the data type, whether the data is categorical or a numerical data. So depending on the data type, we select the graph. So first we go to pie diagram. Uh, if you look at the data on menopausal status, it is a categorical data nominal type with two options, yes and no. So this is a categorical data. And for this categorical data, we can make pie diagram. So this is pie diagram of same. Uh, the premenopausal, which is colored in blue, the premenopausal patients were 65% and postmenopausal patients were 35%. So we can, understand by our visual impression that there are more number of patients which were premenopausal out of total patients. So pie diagram is to represent the data in the form of sectors of a circle. So it is used to depict the composition or proportion of various categories. So to depict what is the proportion out of total, we make a pie diagram. The next diagram is bar diagram. It is very similar to pie diagram with slight differences. For this bar diagram, we take variable uh, from thesis of my student, variable name lymph node stage on column J. So as the variable or attribute have, it is a type of a categorical data, ordinal type. So there were three options, 1, 2, and 3, and it was a ordinal data which can be arranged in a meaningful order because stage 1 is less than stage 2 and stage 2 is less than stage 3. So if there are more than one categories and you need to depict which one is more and which one is less, then you make bar diagram. So bar diagram is composed of either columns or bars, the height of which depend on the frequency. So the number of cases as shown in y-axis, number of cases are more for stage 1, lymph node stage 1 as compared to lymph node stage 3. So we can compare various categories using bar diagram. And since these categories are uh, in a sense independent of each other, they are separate categories, we usually leave some space between the bars and columns. This I'll emphasize later on. So what is a bar diagram? Bar diagram is used to display the values over time spots or between various categories. The example is that number of laboratory tests done in each month of a particular year. So the special type of bar diagram is bar diagram with stalks. Here in bar diagram, the height is corresponds to the central tendency, mean or median, and there are stalks which represent the range of data or variance of data or standard deviation of data. So it is a special type of bar diagram. There is another special type of bar diagram known as composite bar diagram. It is used for visual comparison of many single values with proportions in each one of them. I'll show you with an example. So this is the hypothetical data of the college students in first year, second year, third year. In first year, there were 34 boys and 41 girls. And if you add them, then you will get the total number of students in first year. So I have made this composite bar diagram. In first year, I have made that the height of the this column is about somewhere about 75 or so. And in this single column, it is divided into two for boys and for girls. The orange one is for boys and black for girls. So we can see the composition of boys and girls in first year, second year, and third year in the same graph. So both the things are uh, represented here, total number of students as well as composition. So it is a composite bar diagram. Then we go to line diagram. Line diagram is also for categorical data. So it is similar to bar diagram, but instead of drawing rectangles or columns, we draw a line corresponding to height of each categories. So it is usually used to depict the time trend of a data. For example, in the year 2001, there were 18 students. In the year 2002, there were 30 students. 2003, 32, then 33, then 37. If you make a line diagram, then you can see a rising trend. So we can show a time trend using a line diagram. We can also use bar diagram for same, but to depict the rising trend or a falling trend, we can use line diagram instead of bar diagram. So this was about categorical data. Now we go on to numerical data. For numerical data, we can use histogram. So for the today's example, we will take the variable age, as we know that age is a numerical variable which is a continuous type. So what is the histogram? Histogram is similar to bar diagram, but they are not same. In histogram, the frequencies are plotted along y-axis and class intervals are plotted along x-axis. So this is a summary of data of thesis of my student, uh, which I have shown you. Then this is a classified data. For class interval 20 to 30, there were 4 patients. For class interval 30 to 40, there were 15 patients, and so on. So to graphically represent this, we use histogram. So since the class intervals are consecutive and they are related to each other, unlike bar diagram, the rectangles of histogram, they are usually shown connected to each other. So this is not bar diagram because they are connected to each other. And the difference is that on x-axis, there are not categories, but there are class intervals. So these are the differences between bar diagram and a histogram. So this is a histogram. On y-axis, we have shown frequencies or number of cases here in this example. Uh, then comes frequency polygon. So frequency polygon is obtained by joining frequencies by a line across various class intervals. So we omit the rectangles here, and we just draw a line joining various frequencies. So this is a frequency polygon. And in medical science, unlike other science, unlike economics, management, physical science, in medical science, the our data distribution is usually a normal distribution which take a shape of a bell. So usually we have a bell-shaped curve in a medical science. So this is a frequency polygon of the age data. Then we come to Ogive curve. Ogive curve is the representation of cumulative frequency graphically. So the x-axis represents age. The number of patients less than 20 to 30 is of course 0. Then number of patients less than 30 to 40 will be the sum of the class interval 30 to 40 and this class interval 20 to 30. So it will always increase and it will then reach a plateau here. Example of which will be inverse of this. So here all cumulative frequency polygon. Here cumulative frequencies accumulate various frequencies of various class intervals and they are joined by a line. So Ogive curve can be of types less than and more than Ogive curve. Then we come on to scatter. For this, we need two variables. So we have taken because the thesis one was it was a tumor. We type of the tumor as this slide. So we need two variables, a dot corresponding to the paired data. So there are dots equal to number 30. So this is the scatter of dots, and each dot corresponds to a paired data of two variables. So it is actually used for to have a feel of correlation between two variables. So in scatter diagram, two variables are plotted, one on x-axis, other on y-axis, and data is presented scattered dots, and it is used to assess the nature of correlation between two variables. Then regression line. Uh, when one variable is regressed, a equation of graph is obtained, and it can be graph can be linear or non-linear, and the entire data may or may not be shown as scatter plots. So it is a same scatter plot as I have shown you before. Y-axis there is mitosis, and on x-axis size was per field, and we have drawn here shown in red color. So since the line was almost then we come on to box and whisker plot. It is used for data which is not normally distributed. This is very important. Box and whisker plot is used for data which is not normally distributed, which does not have a bell-shaped symmetric curve. So this is example of weight of students, body weight of students of first year, second year, third year. This is hypothetical data. And if we represent it in the form of box and whisker plot, we get this graph. So we can see that body weight of second year students, less than body weight students and third year students. Probably the second students were in stress and they were eating less as compared to first year and third year students. So in box and whisker plot, it is used for non-parametric data. Here, 2.5th, 25th, 50th, 75th, and 97.5 percentile are plotted. Don't worry, I'll talk about the percentiles in my some other lecture. So you just remember that box and whisker plot is used for non-parametric data, and it is a plot of percentiles of data. Then we come on to second last type of data representation. It is pictogram. In pictogram, by name, it is very clear that here pictures are drawn in front of various categories, and each picture denote quantities like 10, 20, 30, and the total number or value of pictures against particular categories. It will be the example of fruit seller, which have the fruits. He has 60 apples, 40 bananas, 30 grapes, and 50 oranges. This is a hypothetical example. To graphically show this stock of fruits, we can use. So here each fruit represent 10 items. So this one picture of apple represent 10 apples. So there are total of 60 apples, and there are total of 40 bananas, there are total of 30 grapes, and there are 50 oranges. So it is very easy to understand for a layman the data graphically. Then this is last graphical representation, a type of graphical representation known as spot map. Spot map is nothing but it is the data which is shown in the form of scattered dots on a geographical graph. So, for example, this is I have taken from internet. They have shown number of hepatitis patients in a geographical area. So most of the patients are, concentrated in a particular geographical area. This type of information is important for epidemiological studies and health planning. Uh, so this was about graphical representation of data.